All right, we just finished talking about what are indicators and the ones that we would use in part one. Part two of our notes, we're starting with question number 3, is what is an acid, a base, and a neutral? What are these? Now that we know what an indicator is, we know which ones we're going to use to figure it out. What exactly are these? This is the foldable I gave you in class where you're going to add your notes on the inside of your foldable. So go ahead and fold it, add acid, neutral, and base on the outside of it. And then you can go ahead and put 0, 1, 2, 3, 4, 5, 6, 7, and then base with 8 through 14, just like this. And it'll make a whole lot more sense in just a second. So talking about an acid. So when we're talking about an acid, if you were to taste something that was acidic, it would have more of a sour taste to it. It reacts with metals like zinc. When we react to an acid with a base of the same strength, it forms a neutral solution. The pH range is 0 to 6. That's why we added that on the outside here. And it contains an excess of hydrogen ions, like hydrochloric acid, for example. So when we say something would be sour, think like a lemon or a lime, maybe even something like vinegar, coffee. These are all common things that would be acidic. And you might see, hey, what about milk? Milk's not acidic. But think about as milk starts to go bad, we would say milk is sour. So sour doesn't always mean a good thing, yummy. It could mean sour like bad. So keep that in mind. If a solution is neutral, it's not an acid or a base. It's a completely separate solution. If it's neutral, pure water would be a neutral solution, and the pH range for a neutral is 7. If something is a base, it would taste bitter. It might feel kind of slippery. It would react with an acid of the same strength to form a neutral solution. The pH range is 8 to 14 and contains an excess of hydroxide ions. So here you can see things like baking soda, bleach, cleaners, things like that, soap. So it makes sense that it might taste more bitter. If you've had to wash your mouth out with soap, maybe you've had that experience. But hopefully we've all at least washed our hands. And it felt slippery. If you've had to help clean at your house or anywhere before, what you would clean with normally feels kind of slippery or slick feeling to it. And it goes between 8 and 14. So here's a whole version of a pH scale where you can see common things. And if any of us has ever seen the movie Hancock, just hang with me. So in this movie Hancock with Will Smith, they have superpowers. And this is, I don't know what her name is, but his wife, girlfriend, partner. And they've lived for hundreds and hundreds of years. And the closer they get to each other, the weaker they become and the more human-like they become. But the further away they stay from each other, the stronger their powers are and the longer they live. And they keep repelling each other over hundreds of years so that they can continue to live and they always find each other. So the periodic table, the pH scale works similar to this movie because the closer we get to 7, the weaker these acids and bases become. And the further away we get out here, away from 7, the neutral zone, the stronger they get. So it's just like in the movie, the closer they get together, the more human-like they becomes a weak substance. The further away they get, the stronger they become. So for example, things like coffee, we have coffee. You have blood running through your body. You can eat ketchup. You can have a lemon. You can touch soap and you're totally fine. But the further away you get out here, like you shouldn't drink bleach or cleaner. Probably a battery acid would not be a good thing to taste. It becomes a very strong acid or a very strong base. So we need to recognize the strength and weakness within the pH scale.